So now in this video we're gonna talk about the basics. This is a basic electronics video of protecting an LED from a power source, which you generally use a resistor for. So when you have a resistor protecting an LED, you call it a protective resistor. Now when I'm making my videos, I don't explain everything I'm going to explain in this video. If we're using 5 volts in a circuit, I generally say to use at least, you can always go higher if you want, but use at least about 220 ohms. That's a common value, so that's the value I use, but it's also close to the lowest value you want to use. Same with these other values. Now 9 volts, you want to use close to about 470 ohms to protect an LED. These are quarter watt resistors I'm talking about. The wattage though isn't as important as down here. For 12 volts, now it gets to the point where the voltage is so high, the resistor is getting pretty hot. So we use the 1 kilo ohm, a little bit more to protect the resistor than the LED because it's getting close to 1/8 of a watt. But still, it's a good value. The LED should be plenty bright. So now, the main things to be aware of. The LED lights when it's forward bias. So that side of the circuit has to be more positive. That side more negative, or higher voltage, lower voltage, however you want to say that. Generally it's ground over here with the ground symbol, and then a voltage over there which is more positive. There's a 5 volt difference, but in any case, that side got to be more positive, that side more negative. That's called forward bias. If you put it in the other way, it's reverse bias. That's when it blocks a lot more voltage. But in any case, forward bias, it still drops a little bit of voltage. And it depends on the diode. LEDs probably going to be somewhere between about 2 volts and about 3 volts. We'll come to that later on. But in any case, you got the voltage. It has to be greater than the forward voltage, the amount of voltage it takes to conduct. And then it will start conducting at that point. Now it doesn't limit current though, once you got enough voltage to get it conducting. That's why you got the resistor. So you take that forward voltage, we're going to look at examples coming up, and you take the supply voltage minus the forward voltage. That's the voltage across the resistor, and the voltage across the resistor divided by its resistance gives you the current. So first off, let's say you want a red LED. You have a 5 volt power supply. That's the positive side. The negative side, that'll probably be red. That'll probably be indicated by black along the way, or plus and minus. But in any case, red LED, you will know that's probably going to be somewhere around 2 volts. So it does shift a little bit. We'll talk about that coming up. But in any case, that's its forward voltage. The voltage difference you need across here before it starts conducting. Now, it doesn't limit current once it really starts conducting, and so the voltage builds up on the other component. We got one more along here, and when it comes to power supplies and series components, each one of them is going to have part of that voltage. So we got 3 volts across that one, 2 volts across that one. You add them together, you got 5. So they split up the voltage. That's whenever you got series components. Now we got the 3 volts across the resistor. You can see we got, if it's a 220 ohm resistor, 3 volts divided by 220 is somewhere around 14 milliamps. So that's a little bit high. You want to limit current to no more than 20 milliamps through an LED. So I don't mean high as in you might damage the LED. It's just you're getting somewhat close to the 20 milliamps. And the more current going through the LED, it kind of lifts the voltage that it drops a little bit. But in any case, you got that current. Now you take current. We're just going to look at the resistor now, because the LED, you just got to limit the current. You don't have to worry about wattage. With the resistor, you got to worry about wattage. So that's current in amps times voltage in volts. And so that's going to be about 0.042 watts. So these are usually rated for 0.25 watts. You want to keep it below 0.125 watts to be safe. And we're well below that. So now we're going to come to the blue LED, and it's going to probably drop about 3 volts, especially as current goes up. And so it's dropping more voltage though, and so we're going to have less across the resistor. It's going to pull down how much actual current is flowing right there. So even though it's the same circuit there, different color LED, it's dropping a little more voltage, and so we got less voltage across the resistor, we got less current. Pretty straightforward right there, current law. And now doing the power, the blue LED is not going to get as hot. There's another nice thing though. These cool color, blue, green, and even white LEDs, they all build up about 3 volts across them, but they get really bright when you put current through them. If you put the same current through the blue one as you do with the red one, the blue one gets a lot brighter. In fact, in this circuit, with the same value resistor, the blue LED, even though it has less current, it still gets probably quite a bit brighter than the red one. So I usually use a higher value resistor to limit the current more. They are pretty efficient. So in any case, let's move along. As I said before, we have that forward voltage. So I said maybe it's 2, maybe 3 so far. But at very low current, a red LED is probably going to start getting a faint glow somewhere when you get about 1.5 volts across it. And as you get more current going through it, you use a lower value resistor or whatnot. When you get close to 20 milliamps, it's probably going to be about 2.2 volts built up across it. And so they do a little bit to limit the current, because as more current goes, they need more voltage, and thus there'll be a little less current mathematically. But in any case, that's about the maximum though, where it's going to start dropping voltage. And so you still need a resistor no matter what. The blue LED. So I said, you know, somewhere around about 3 volts. But if you get very low where it's just barely glowing, it's probably going to be somewhere around about 2.5 volts built up across it. And as current goes up, you get close to 20 milliamps, about 3.2 volts. Now, circuits, if you just light an LED or whatnot, but generally LEDs turn on and off in basic electronic circuits. So usually you're either cutting off all the voltage. That's when the LED is off. That's because a switch or something else is taking away all of the voltage. And if you got practically an infinite amount of resistance, then you got no current flowing. And that's the same as no voltage. Now you close the switch, you have a direct connection. It's like connecting a piece of wire to the voltage source. And if it's a mechanical switch especially. And so you got practically no resistance. It's basically like it doesn't exist at that point. As far as the circuit is concerned, you just do the calculations with the component for how much current they will have when the switch is on. And so now we're on the board. The LED is off because the output's off. Right now the power supply is like an off switch, as I said before. It cuts off power. So this is going to be an estimated amount of current, not as accurate as measuring current with the meter, but it's much more convenient. You can see somewhere about 12 milliamps of current. Well, the red LED is lit up. Remember, you got to put them in the right direction, the forward bias direction. And so there's the blue LED. And so you can see we had 12 before. Now it looks like about 8. So much less current. And those are pretty close to the values that we did the calculation for. So now I put it in backwards. You can see it doesn't light up. It's very important that you put them forward bias. And so that's the long lead. Needs to be more positive. Short lead, the cathode, needs to be more negative for it to light up. It just blocks a lot more voltage. Reverse bias, you don't want to exceed whatever the particular diode's breakdown voltage is. Well, it's reverse bias because you'll destroy it. So now we have the meter set to measure voltage. We're going to look at the voltage. So you may have noticed on the power supply it says 5 volts. It's a little bit above 5 because we lose just a speck of voltage along the way. But in any case, there you can see once I get a good connection, we have a good solid slightly more than 5 volts right there. Now we're going to go across the LED. So I can either go to the resistor or to the LED directly as long as it's electrically the same spot. And there you can see we're a little bit above 2 volts right there. And so that's the voltage across the LED. And we'll have the rest of the voltage across the protective resistor right there. So about 3 approximately. And then we did the same comparison with the blue LED, which you can probably tell is a whole lot brighter. We already saw that it has even less current going through it. So first we're going to do the LED, about 3 volts across it. So that leaves about 2 volts approximately across the resistor right there. Now, as I mentioned before, at lower currents it's going to go down. And so one thing we can do, actually we got another resistor right there. So we're going to swap that out. This is a 220 ohm resistor. We're going to use a 1 kilo ohm resistor, which will get us about a fourth of the current. There you can see it's not even showing any current on the power supply right there. It's that close to 1 milliamp of current, and the blue LED is still fairly bright. As you can see there, let's look at the voltage across it right now. And you can see it went down a bit, so not a terrible amount, but it did go down a bit. And of course the rest of the voltage across the resistor. Now we're going to pop it out, and the red LED is probably going to be fairly dim right here. So let's once I get it in, there you go. So we those numbers don't mean anything. When I was touching the probe, some numbers came up, but there you can see it went down a little bit right there. And so it's not as dramatic as I thought, actually. So that's good. But there you can see we got a little more voltage across the resistor than we did before. But in any case, there you can see hardly any current, again, for the red LED right there. Now we can go even lower by just lowering the supply voltage. So we saw that this will start lighting a little bit at about 2 volts. Let's take a look. See if we got like a little glow at all. And there you can see a faint glow. In this meter, the light automatically came on because it was dark enough. So we got a little bit of conduction. And there you can see we're down, you know, somewhat close to the 1.5 volts. So we got a little bit of conduction. But in any case, these tests are fun. You can do them for like half the day or something as you think about them. But this video has gone on long enough. So hope you enjoyed. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, that, donate to Patreon if you can. That helps out the most, but just watching videos helps out a ton. Thanks for that. I will see you in the next video.